Morning student. Today we will solve the examples based on elevation in boiling point and depression in freezing point. Example 1. First example. 18 gram glucose. 18 gram glucose is dissolved in 1 kg water at which temperature will water boil at 1.013 bar pressure. Kb for water is 0.52 Kelvin kilogram mole inverse. In textbook example number 2.7. Now how to solve this example? 18 gram glucose. So glucose is a solute, mass of solute is given. Remember for our notation, 1 means solvent, 1 means solvent, 2 means solute. Now 18 gram glucose is given, that means W2, value of W2 is given 18 gram. Is dissolved in 1 kg water, that means mass of water is given 1 kg, that means 1000 gram. Mass of solvent is given. At which temperature will water boil? That means glucose is added in water. We have to find the boiling point. That means solution is prepared. That means we have to calculate the TB. TB means boiling point of solution. We have to calculate at 1.013 bar pressure. That means 1 atm pressure. Solvent is water. That means water having boiling point at 1 atm pressure is, we know, it is 100 degrees Celsius. That means 373.15 Kelvin when it is converted into Kelvin. Now Kb for water is given. Kb equal to 0.52 Kelvin kilogram mole inverse, it is given. Now 18 gram glucose, solute is glucose, that means molar mass. Molar mass of glucose we know 180 gram per mole. Now we have to calculate TB. That means first we will calculate delta TB. That means delta TB. We know the formula of delta TB equal to Kb into W2 into 1000 divided by M2 into W1. Now value of Kb is given 0.52. 0.52 W2 value is 18 into 1000 divided by M2. Molar mass of solid is 180 and W1 that means mass of solvent, that is 1000 gram. That means 1000 cut here 10, that means 0.052 Kelvin. Delta Pb is there. Now we have to calculate the value of Pb. So second step is there. First step, delta Pb equal to Pb minus Pb0. So value of delta Pb is 0.052. Pb we have to calculate. Pb0 373.15 Kelvin. Now Pb, that means this is the left side. That means then we are simplifying the answer of Pb. That means boiling point of solution 373.202 Kelvin. This will be the answer. Now second example. Boiling point of water. Boiling point of water at 750 mm Hg pressure is given 99.63. How much sucrose is to be added to 5 gram or 500 gram of water such that it boils at 100 degrees Celsius. Intake question 2.10. Now boiling point of water is given at 750 mm Hg pressure. That means boiling point of water means PV0 is given 99.63 degrees Celsius. How much sucrose is to be added? That means sucrose is solute. How much? That means we have to calculate the mass of sucrose. That means W2. W2 we have to calculate. Sucrose is there. That means molar mass. We know the molar mass of sucrose is 342 gram per mole. Sucrose having formula C12H22O11. This is known as sucrose. The molar mass will be 342 gram per mole. To 500 gram of water, that means value of W1 is 500 gram. Such that it boils at 100 degrees Celsius. That means value of PV equal to 100 degrees Celsius. That means we know PV0 and PV, so we can easily calculate delta PV. Now, the step 1 will be calculation of delta PV. So delta PV equal to PV minus PV0. The value of PV is 100 degrees Celsius minus PV0. PV0 is 99.63. That means 0.37 degrees Celsius. Otherwise, it is the difference. That means degrees Celsius or Kelvin difference will be same. Now we have to calculate W2 to write the formula of delta PV. So delta PV equal to KB into W2 into 1000. That means N2 into W1. Now we have to calculate the W2. That means W2 equal to delta PV into N2 into W1 divided by KB into 1000. Now delta PV is 0.37. M2 molar mass 342. W1 is 500 gram. Now KB. Solvent is water. For water, we know very well Kb equal to 0.52 Kelvin kilogram mole inverse. So Kb equal to 0.52 into 1000. Then this can be simplified. You will get answer this. That means 1 to 1.31 gram. So 1 to 1, that means 121.7 gram sucrose is required. Now next example is third example. 45 gram ethylene glycol is mixed with 600 gram water. Calculate 1. Freezing point depression. Second one is freezing point of solution. Value of pH is given. Water is solvent. Value is 1.86 Kelvin kilogram mole inverse. Example 2.9. So how to solve this example? 45 gram ethylene glycol is given. That means here ethylene glycol is a solute having mass. That means W2. Before that, remember 1 means a solvent. Again 2 means a solute. Remember. Notation. That means W2 is given 45 gram. Having molecular formula C2H6O2, that means obviously we can calculate molar mass. It will be 62 gram per mole. Is mixed with 600 gram water. That means Mass of water, that means W1 is 600 gram. Calculate freezing point depression and freezing point of solution. Kf is given. The value of Kf equal to 1.86 Kelvin kilogram mole inverse. Now we have to calculate delta Tf, that means freezing point depression, and second freezing point of solution. That means we have to calculate Tf. Now solve this water. So for water, freezing point is, we know freezing point of solvent water 0 degree Celsius. That means it will be 273.15 Kelvin. Now first calculate delta Tf. Using this formula, delta Tf equal to Kf W2 into 1000 divided by M2 into W1. That means value of Kf is 1.86. W2 is given 45 gram into 1000 divided by M2, that means molar mass is 62, and W1 in gram 600 gram. Now when this can be simplified, answer will be this much, that means 2.2 Kelvin. That means delta Tf equal to 2.2 Kelvin. That means depression is freezing point. That means freezing point depression is 2.2 Kelvin. Now use this formula, delta Tf equal to Tf0 minus Tf. Now value of delta Tf is 2.2. Tf0 is 273.15. We have to calculate Tf. When this Tf calculated, so answer will be 270.95 Kelvin. The freezing point of solution. Now next example, calculate the mass. Calculate the mass of ascorbic acid. That means vitamin C. Is vitamin C. Okay. Having formula C6H8O6 to be dissolved in 75 gram of acetic acid to lower its melting point by 1.5 degrees Celsius. Kf is given 3.9 Kelvin kilogram mole inverse. In text question 2.11. How to solve this example? Again remember, 1 means a solvent, 2 means a solute. Calculate the mass of ascorbic acid to be dissolved in 75 gram of acetic acid. That means ascorbic acid is solute. We have to calculate the mass, that means W2. We have to calculate W2. Now ascorbic acid, that means vitamin C, having formula C6H8O6. That means we can calculate molar mass. The molar mass is 176 gram per mole. To be dissolved in 75 gram of acetic acid. Acetic acid is here solvent. Mass is given, that means W1 75 gram. To lower its melting point, that means freezing point, by 1.5 degrees Celsius, that means value of delta Tf is given 1.5 degrees Celsius. Now this is the temperature difference, that means value will be same in degrees Celsius or Kelvin. Value will be same. Now Kf is given. So Kf is 3.9 Kelvin kilogram mole inverse. Now we have to calculate the W2. All values are given. So use this formula, delta Tf equal to Kf W2 into 1000 divided by M2 into calculate the W2 mass of solid. That means W2 equal to delta TF into M2 into W1 divided by KF into 1000. Value of delta TF 1.5, M2 is 176, W1 is 75 gram, KF is 3.9 into 1000. When this can be simplified, we will get answer 5.077 gram. That means answer W2 equal to 5.077 gram is required to lower the melting point by 1.5 degrees Celsius. Next example is 5% solution by mass of cane sugar in water has freezing point 271 Kelvin. Calculate the freezing point of 5% glucose in water if freezing point of pure water is 273.15 Kelvin. Exercise 2.20 number. How to solve this example? 5% solution by mass of cane sugar is given. So initially data of cane sugar. Cane sugar means sucrose. Cane sugar means sucrose. Now 5% solution means 5% solution is given. That means 5% solution W by W. That means in 100 gram solution 5 gram is sucrose. That means W2 is 5 gram and the W1 remaining is water, which is 95 gram. As a freezing point is given. That means value of TF is given, which is 271 Kelvin. Calculate the freezing point of 5% glucose in water. Okay, if the freezing point of pure water is given, that means TF0 is given, which is 273.15 Kelvin. So from that we can calculate the delta TF. So delta TF equal to TF0 minus TF. So we will get 2.15 Kelvin. The value of delta TF is 2.15 Kelvin. Now here value of KF is not given. So step number 1 is we have to calculate the KF. That means using this formula, delta TF equal to KF W2 into 1000 divided by M2 into W1. So therefore KF equal to delta TF into M2 into W1 divided by W2 into 1000. Now delta TF is 2.15. Now M2, that means molar mass of solute. Here sucrose is there. That means automatic M2. Sucrose for M2 molar mass is 342. That means M2 is 342. W1 is 95 gram. Now W2 is 5 gram into 1000. Now when this can be simplified, you will get answer 13.96 Kelvin kilogram mole inverse. That means KF is calculated. Now once the KF can be calculated, then now again solution is given. KF remains same. Aqueous solution is there. That means now apply this KF for calculation purpose of glucose. Now again glucose solution is given having 5% concentration. So 5% W by W. Glucose solution is given. So again W2 equal to 5 gram and W1 equal to 95 gram. Again M2 glucose is given, that means 180 gram per mole for glucose M2. Now we have to calculate the freezing point. That means first we calculate the delta TF. We are going to calculate TF. Okay. So first we will calculate delta TF. That means apply formula delta TF. Delta TF equal to AF into W2 into 1000 divided by M2 into W1. Now value of KF we have calculated 13.96 W2. W2 is 5 gram into 1000 divided by M2. M2 for glucose is 180 and W1 is 95. When this can be simplified, you will get answer 4.08 Kelvin. Delta TF is calculated 4.08 Kelvin. Now we have to calculate the TF. That means delta TF equal to TF0 minus TF. That means delta TF is 4.08. Now TF0. TF0 means freezing point of water. Freezing point of water is given 273.15. That means 273.15 minus TF. Now when this can be simplified, TF will be 269.07 Kelvin. So this will be the answer. That means freezing point of 5% glucose solution is 269.07 Kelvin. First calculate KF, then delta TF, then TF. Now next example is two elements A and B form compounds having formula AB2 and AB4. When dissolved in 20 gram of benzene, 1 gram of AB2 lowers the freezing point by 2.3 Kelvin. 1 gram of AB2 compound, whereas 1 gram of AB4 lowers the freezing point by 1.3 Kelvin. Here, that means molar depression constant for benzene is given 5.1 Kelvin kilogram mole inverse. Calculate the atomic mass of A and B. Exercise question number 2.21. So how to solve this example? Here two compounds are given AB2 and AB4. So separately we will calculate the molar mass of each compound. That means first information for AB2, calculation for AB2. So AB2 mass is given. AB2 compound, that means W2 is given 1 gram. Now 20 gram benzene in which is dissolved, that means W1 is 20 gram. Freezing point lowers by 2.3 Kelvin, that means delta TF equal to 2.3 Kelvin. Now KF is same, so KF equal to 5.1 Kelvin kilogram mole inverse. Okay. Information for AB2. M2, that means MAB2, we don't know. So first calculate molar mass, that means using this formula delta TF equal to TF into W2 into 1000 divided by M2 into W1. that means MAB2. For AB2 compound, molar mass equal to KFW2 into 1000 divided by delta TF into W1. The value of KF equal to 5.1. Now W2 is 1 gram 1000 divided by delta TF. Delta TF is given 2.3 and W1 20 gram. When this can be simplified, you will get answer 110.87 gram per mole. That means MAB2 is 110.87 gram per mole. Now for AB4 compound, use information. For AB4 compound, mass is also same. That means W2 is 1 gram. Mass of solvent is also same. That means W1 is 20 gram. Now delta TF is 1.3. So delta TF is 1.3 Kelvin. KF will be same, solvent is same. So KF equal to 5.1 Kelvin kilogram molecular. Now we have to calculate MAB4. That means molar mass of AB4 compound. So similarly, using this formula, that means MAB4 equal to KF W2 into 1000 divided by delta TF into W1. Now value of KF is 5.1. W2 is 1 gram into 1000. Now delta TF is here 1.3 and W1 is 20. So when this can be simplified, you will get answer 196.15 Kelvin. Gram per mole, molar mass is 10 gram per mole. That means MAB4. Now molar mass of AB2 compound and AB4 compound is obtained. We have to calculate the atomic mass. So simple calculation is there. Suppose atomic mass of A having small a and B having small b, then we can write A plus 2B. When A is the atomic mass of element A, B is the atomic mass of elements B. So 2B equal to 110.87, equation number 1. Now again, A atom having atomic mass equal to small a, that means A plus. Now AB4 compound, the atoms of the elements are 4 to 4B. 4B equal to 196.15, equation number 2. Now this equation can be solved by elimination method. That means subtracting equation 1 from 2, then you will get 2B equal to something. Then from that you will calculate B, and again substituting the value of B in any equation 1 or 2, you will get answer the value of A. The answer will be, when these two equations are solved by elimination method, then answer of A equal to 25.59 U and the answer of B equal to 42.64 U. That means atomic mass of elements A is 25.59 while B is 42.64.